What is up, everybody? We have made it to rectangles. And as I previously stated, everything from parallelograms applies to a rectangle. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. All right? So now we're just going to be adding on a little more detail. So again, opposite sides are parallel, opposite sides are congruent. Okay. Our add-ons now are all four angles are right angles. So it still stays true to what I previously said, as in opposite angles are still congruent, consecutive angles are still supplementary, but now we know that if it's a rectangle, all four angles are right angles. Okay. The next thing has to do with diagonals. So remember previously from a parallelogram, the diagonals bisect each other. With a rectangle, they still do that, but the diagonals are also going to be congruent. So if I were to connect a segment from A to C and from B to D, those two segments would be the exact same length. So technically, I can mark my rectangle like this, where all of those segments are congruent. Okay. So before I get to that next one, I just want to point out also, when we draw our diagonals, we have four triangles. 1, 2, 3, and 4. Within a rectangle, triangle 1 and 3 are congruent, and triangle 2 and 4 are congruent. So whenever you draw the diagonals in a rectangle, you'll have two sets of congruent triangles. So if I know that this is a rectangle, and I know that PS is 180 and PR is 200, what is the length of QT? So again, PS would be 180, PR, so that's this entire length right here, is 200. So then, remember, diagonals are congruent, so that means all of these diagonals pieces right here are congruent. So if PR is 200, then PT and TR are each 100. Well, if those are each 100, then QT is 100 as well. And if I want to find SR, which would be this length right here, remember we have four right angles, so technically I have a right triangle right here. So what I would have to do is I would have to use Pythagorean theorem. PRS, I know PS is 180, I know PR is 200. So then from here, let's just call this X. X squared plus 180 squared equals 200 squared. So then X squared plus 180 squared is 32,400 equals 200 squared. That's going to be 40,000. So 40,000 minus 32,400, X squared equals 7,600. Square root of 7,600 is 87.2. So that missing length is 87.2. Alright. So the thing to remember, guys, and actually as we get into rhombuses and squares on the next lesson, we do have a lot of right angles. So anytime you have right angles, think Pythagorean theorem could be a possibility to find some missing sides, because we can always make right triangles out of these figures. Okay. Looking at this diagram here, okay, so again, given that this is a rectangle, we want to find the following pieces of information. So I know that DC is 7, which means that AB would also be 7, because those are opposite sides. AC, well, I know DE is 5. I know that these are all congruent. So that means that the length of AC would be 5 times 2, or 10. AEB, that is this angle right here. Well, I know that angle is supplementary with angle 67. So I can just do 180 minus 67. That gives me 113 degrees. And then finally, EBC. EBC is this angle right here, okay? Now this one's a little bit tricky, so you kind of piece it together a little bit. Well, I know that this angle here is also 67 degrees because it's vertical with the 67 on the left. And the key to doing this problem now is knowing that this triangle right here is an isosceles triangle. And remember guys, isosceles triangles have two angles that are congruent, the base angles. And those are opposite the congruent sides. Well, we have our congruent side here and our congruent side here. So that means that the angles across from them are going to be the same measure. So this would be a double arc, and I have a double arc here. Well, I know that our vertex angle is 67, so if I call this x and this x here, I know that all three angles within that triangle have to add up to 180 degrees. So that would give me 2x equals 180 minus 67, I know is 113. So 113 divided by 2 is 56.5. So that missing angle measure of EBC is 56.5 degrees. Let's do a couple more examples, and then that'll be it for the notes for today. So again, JKLM is a rectangle. Angle JKL is 2x plus 4, and angle JLK is 7x plus 5. Find x. Oops, I read this problem wrong, sorry. KJL. KJL is this angle right here. And then, so that would be 2x plus 4. And then angle JLK is 7x plus 5. That's this angle here. So we're trying to find x. Now this problem involves alternate interior angles. So remember, our top and our bottom lines are parallel. And then we also know that this diagonal is a transversal. So knowing that, this angle is alternate interior angle with the 2x plus 4. So that means that this one is also 2x plus 4. And the final step to understanding this problem is how much is this entire thing? Well, if it's a rectangle, that has to be a right angle. So the relationship between our equations is that they are complementary. They add to 90 degrees. So it would be 2x plus 4 plus 7x plus 5 equals 90 degrees. So from there, 9x plus 9 equals 90. 9x equals 81. So x equals 9. And then another kind of problem for this one. So JP is 3y minus 5, and MK is 5y plus 1. Find y. So let's see if I can get some overlapping colors here. So it says JP is here, purple, and then MK is green. So remember, each one of these pieces are congruent, so that means purple is half of green. So to make them equal, you could either do 2 times 3y minus 5 equals 5y plus 1, or you could do 3y minus 5 equals 1/2 times 5y plus 1. I would recommend doing it this way to have the fraction come out at the end if needed. So distribute the 2, 6y minus 10 equals 5y plus 1. Subtract the 5y, add the 10, y equals 11. All done. One more. Okay, so first part is looking at segments, second part is looking at angles. So FD, which is our entire length here, is 3x plus 7. EG, which is this length here, is x plus 5. We know that those are congruent, so that would be 3x minus 7 equals x plus 5. Subtract the x, add the 7, 2x equals 12, so x equals 6. Pretty easy one. For the next one, angle EFD is 2x minus 3, e to f to d, so that's this angle here. Angle DFG is here, x plus 12. We know that this whole angle is a right angle, so it would be 2x minus 3 plus x plus 12 equals 90. 3x plus 9 equals 90. 3x equals 81. So x is going to equal 81 divided by 3 is 27. Enjoy the homework. Let me know if you have any questions. Talk to you soon.